You ever stare at a math problem that's just a wall of text and think, where do I even begin? Yeah, we've all been there. The tricky part usually isn't the math itself, it's figuring out how to turn all those words into an actual equation. So today, we're going to do just that. We're cracking a word problem from a real exam paper, step by step, to find that one magic number that solves the whole thing. Let's jump in. So, here it is, our case file. This is question 2 from an exam paper, kind of randomly tucked between questions about set theory and solar panels. And at first glance, it just looks like a little riddle about 3 people, a do, Tenko, and a Korfa. But trust me, to get the right answer, we've got to put on our detective hats and translate these clues. And this is what it all boils down to. After we wade through all the relationships and the numbers, our entire investigation is laser-focused on finding this one specific piece of info. This is our target. So, the big question is, how do we get from this paragraph of English to a single clean number? Well, you could think of it like a code. And right now, our job is to crack it. Let's do this thing together. All right, first things first, any good investigation starts by carefully examining the evidence. So let's break this problem down into the 3 key clues they've given us. Okay, here's clue number 1. This is really the heart of the whole mystery because it connects all 3 of our people. The word product tells us we need to multiply their ages, and 9 less than means we'll be subtracting. This one sentence, this sets up the main relationship we're going to work with. And now for our second clue. This one gives us a super simple direct link between Tonko and Adu. We now know Tonko is exactly 4 years older. That's a crucial piece of the puzzle that's going to come in handy very, very soon. And finally, our third piece of evidence. This one connects a Korfa directly to Tenko. Now, hang on. Did you catch that? Tenko is the one connecting everybody. He connects to Adu, and he connects to a Korfa. That's a massive hint about how we should probably tackle this. So, now that we've got our clues laid out, it's time to translate them from plain English into the language of problem solving. Algebra. This is where things get really precise. To make our lives easier, we're going to give each person's age a simple letter, a variable. We'll use A for Adu, T for Tenko, and K for a Korfa. Nice and clean, ready to go. And just look at how neatly those English phrases turn into math. Product becomes multiplication. Less than is subtraction. Older than is just addition, and times is multiplication. And just like that, our 3 clues have become 3 perfect equations. Our case file is now officially written in the language of algebra. Okay, so now we have 3 equations, which is still a little messy, right? So our next move is to combine them. We're going to synthesize all this evidence into one single, powerful equation that we can actually solve. Now, watch this. It's kind of cool how it works. We start with our main equation. We already know that K is just another way of saying 6t, so let's just swap that right in. Boom! Now we're down to 2 variables. But wait, we also know t is the same as a plus 4, so we can substitute that in too. And just like that, we've boiled everything down to one equation with only one unknown variable, a. So now let's just clean this up by expanding out the brackets. On the left side, a times a plus 4 gives us a squared plus 4a. And on the right, we get 6a plus 24. This is just a little bit of algebraic housekeeping before we get to the final form. And here we are. By moving every single term over to one side, we get this, a classic quadratic equation. Just think about that. That whole word problem, all those different clues, they've all been funneled down into this one elegant line of math. This is the final code we need to crack. All right, this is the moment of truth. We've got our equation, and now we just have to solve it to find our first real answer, the value of a, which is Adu's age. So the classic way to solve this is by factoring. We're just looking for 2 numbers that multiply to give us -15 and add up to give us -2. After a second of thinking, yep, it's got to be -5 and +3. This lets us break the equation down into 2 simpler parts. A -5 times a plus 3 equals 0. Now, here's the thing. If you multiply 2 things together and the answer is 0, one of those 2 things has to be 0. That leaves us with 2 possible realities. In one world, a minus 5 is 0, which means a would be 5. In the other world, a plus 3 is 0, which means a would be -3. Okay, but let's pause for a second. The math gave us 2 answers, but now we have to use a little common sense. Can a person actually be -3 years old? Yeah, no way. So we can just toss that -3 answer right out the window. It doesn't make any sense in the real world. That means Adu's age can only be one thing: 5. And just like that, we found the first piece of our puzzle. Awesome, we've got Adu's age. But let's not forget our main mission here. We need to find Akorfa's age. Now that we have this first key piece of information, the rest of this should be a piece of cake. This part is like watching dominoes fall. It's pretty satisfying. We know Aju is 5. And remember that second clue? It said Tonko is 4 years older. So 5 plus 4 gives us 9 for Tonko's age. Then our third clue said Akorfa is 6 times Tonko's age. So 6 times 9 is 54. And there it is, the solution to our entire mystery. Akorfa is 54 years old. We did it. We successfully translated that whole paragraph of words into one single definitive number. Case closed.
So, what's the big takeaway here? This wasn't just about finding Akorfa's age. It's about having a method, a kind of detective's toolkit you can use for any word problem. First, you deconstruct the problem into clues. Then you translate those clues into math. You synthesize them all into one big equation, solve for your first lead, and then use that to find the final answer.
You know, it just goes to show you that behind a confusing wall of words, there's often a simple, logical puzzle just waiting to be cracked. Which kind of makes you wonder, how many other complicated-looking problems out there are really just simple math waiting for us to decode them?